I am GLink. I work for Fairwinds Technology. My current acting role is a VP of Engineering. So I'm in charge of all the engineering and all the development efforts currently in Fairwinds.
Can you give us an overview of GLink and what it consists of?
So GLink is a Fairwinds product that was developed as part of a SIBR, and it's eventually transitioned developed over the years and innovated over the years to turn into a large bandwidth 4-channel combiner. So the box you see in the center there, which is the GLink, resides inside of that, and that's the ruggedized enclosure. You can hook up to 4 antennas, transmit and receive on this. We're antenna agnostic, meaning we don't care if the transmission band's Ka, Ku, X band, or C band. We operate in the L band, so that's why we're antenna agnostic. So it's a 4x4 digital switch matrix. So what makes this unique beyond just switching is we have the ability to combine antennas to increase performance. So we can combine any combination of 2 antennas or 3 antennas or all 4 antennas, or we can treat all the paths independently. So you could have antennas pointed at different satellites and be switched to different modems based on mission needs and use cases. Additionally, we have interfaces where we can control and configure the modems. So right now, GLink provides configurations for the 2050E, which is an EBEM or mil standard compliant modem, as well as the CDM 760. And those APIs can be developed and easily integrated inside of GLink to expand for future modem capabilities as they arrive. Yeah, so another unique capability of GLink is network management or remote management. We provide a SNMP v3 interface on GLink, which allows this to be easily integrated into a local MNC or brought back into like enterprise management control system for insight and visibility of what's going on with the node. So this allows an operator, local or remote planner, to push in configurations based on mission needs, so that you can align antennas to specific satellites or constellations and services.
Let me go to the next slide, the one with the spectrum analyzer graph. Can you explain what we're seeing here on this as you add more antennas and using the GLink capability?
Yeah, so this slide is demonstrating the ability to increase receive performance. So where this is applicable and where this benefits DoD, especially in a tactical environment, is you can reduce your logistics footprint and bring out common smaller antennas that would be equivalent to a much larger antenna that's more difficult to transport and set up. So what you're seeing here is as you increase the number of antennas, you're increasing the receive performance, which is the graph in the middle here. So it shows the 1 antenna, 2 antennas, 3 and 4 antennas. So the data you're seeing here is actual data that was collected in real time, looking at one of the modems that we had hooked to the system. So what you're seeing here is an increase in signal level, or EBNO or ESNO, which also translates into your receive performance and your overall receive throughput.
Okay, can you tell us about the GLink history, how it started and where we're going to?
Yep, so GLink started out as an Army SIBR, so we've progressed from the phase 2, and then we had a follow-on contract with the Army called MAMS. So the big change between the phase 2 and MAMS is we went through a small band with what we called SCPC, which is narrowband combining, where you target specific signals and combine it. And then the improvement from the phase 2 to MAMS is we went into what we call wideband or FDM combining mode, which allows us to combine 500 megahertz or greater bandwidth instantaneously, which would cover majority of use cases, all your commercial use cases, and a good portion of your DoD commercial use cases. So you can combine every signal within a 500 megahertz instantaneous bandwidth. And then this transitioned into our first product, GLink, where we took MAMS in phase 2, which was on a test bench, and then turned it into our first product, or ruggedized product, which is a transit case, which is shown down there. It's the same capability, but just at a ruggedized case. And it also contains the front ends. And where we're going in the future here is where we're going to reduce the size of this with this Global Link Next Gen, which significantly reduces the size and weight of the product and provides the same capability of what we had in Global Link, plus some additional enhancements. Instead of just doing 500 megahertz, we can do a full gigahertz bandwidth. So that would allow us to combine all the signals in L-band that would cover any type of commercial or DoD application that exists today.
Great.